So as the previous video for modelling geometric growth and decay showed, the increase in geometric sequences goes up and up each time. So you can see here with compound interest, which is geometric growth, the increase is going up every time. So here we've got 1 coin, then we've got 2, then we've got 4, then we've got 8, then we've got 16. So every time the difference has changed. We've gone up by 1, then we've gone up by 2, then we've gone up by 4, then we've gone up by 8. So in actual fact, what this has done is it's times by a common ratio every time. So this is times by 2 every time. And so you'd expect the curves like these to go up and get steeper and steeper. And so compound interest is generally considered in the finance world as being one of the most important lessons you can learn from a young age, because the more you save early on and the longer you give your investment, the steeper the curve will get. So at the end of your career, you can either make it to this point on the curve, okay, or you can make it to this point on the curve, with the dollars being on the left there. So the difference can be enormous if you have started saving only a small amount of time earlier. So that's what we're going to look at today, and we're going to apply it using what we call a compounding table. So a compounding table is what you would see like a balance sheet use. So something that explains it step by step, from somewhere like the bank would give you these things. So to start with, we're going to have our starting amount, okay, 7,500, which is effectively V0, and we're going to apply the interest A, we don't know what A is, to give us $450 of interest, and that's going to be added on. Okay, and then that gets carried over to the next period. So this next period here you'd expect to be 7,950. So to work out what A is, we know what B is. B is 7,950. To work out A, we need to work out what rate that was applied. So if 450 out of 7,500 is set as a fraction to times 100, that will give us the percentage. So let's just work out what that is. Okay, so we get 6%. So this is a 6% interest. So A is 6. Okay, and that matches up with the rest of the table. So obviously this bank account has a set amount of interest and it doesn't change throughout this example. If we want to know what C is, so the compounding table works out every time based on the new amount that you start with. So C will be using the value there, 7,950. So C is 7,950 again. And that gives us a new value of 477. So this is higher than the last time. And this is the effect that compound interest has. Every time you increase your bank balance, the interest will go up for the next period. So you expect to earn more and more each time. So D, this number here, will be the sum of the 7,950 plus the new interest of 477 to give us the new value, 8427. Which adds up to the same as there, because that's carried over to the next period. This next row is done for us, so 6% of 8427 is 505.62, and then that's carried on down there. Again, that bit's done for us, and now it's asking us to find E. So E is the sum of 8932.62 plus 50535.96, and that will give us the new value. So let's just put that in the calculator. $4,969. 9469, so that's E. E equals 9469. And then lastly, that gets carried over to the next period. So this is how compounding interest works step by step. Okay, and it's important you understand that, because when we start using the formulas for it, you need to understand what happens each time. In my next video, we're going to look at doing it recursively, and then we're going to use formulas.